Hey everyone, we're going to work on practice sheet number 3 for stoichiometry, problem number 2. So we had a mistake in the other one, so we're going to make a new video for this one, and we're going to go ahead and show you exactly how to answer this mass stoichiometry problem. So the first thing we have to do is identify what we have. So we have nickel 2 nitrate. It's going to combine with sodium hydroxide to produce nickel 2 hydroxide and sodium nitrate. So the first thing we have to do is we can go ahead and put in the charges up above. So nickel is going to be a +2. And if I keep it down, nitrate is going to be a -1. Well, how do we know that? Let's go ahead and look at our polyatomic ion sheet. Here's our polyatomic ion sheet, and we go to nitrate. Nitrate is NO3. It's a -1. Okay, so how did we know that our nickel? Well, the nickel was 2 because we have that Roman numeral there. Since they do not cancel each other out, we crisscross. And so that means we're going to have 1 nickel and we're going to have 2 nitrates. Okay, so let's go ahead and start that one down here. And I'm just going to let this go a little bit here. So we're going to have nickel 2. So the symbol for nickel is going to be Ni. Okay, then we only have 1 of those, but we have 2 nitrates. And if you remember from going to the other sheet, nitrate was NO3. And since we have 2 of them, we put our parentheses and our subscript there. So there's our nickel 2 nitrate. Okay, we're going to add to that, or it's combined with sodium hydroxide. So plus sodium hydroxide. Sodium is going to be, and if I go down to that, sodium is going to be a +1, where hydroxide, okay, it's a -1. Again, how did we get that? Well, if we go to our periodic table, sodium is right here. It's in column 1A. That makes it a +1. Our hydroxide is on our polyatomic ion sheet, and we notice it's OH, and it's a -1. So go back to our problem. So when we write this one out, we're going to have our sodium, which is Na, and since they cancel each other out, it's just 1 of each one, and then our OH for our hydroxide. Now that's going to yield, okay, nickel 2 hydroxide. So again, if I scroll down this way, my nickel is going to be a +2, and my hydroxide is going to be a -1. I get that one from the previous one. That means we've got to crisscross. That means that I need 2 hydroxides. So we're going to have 1 nickel. So that's going to be Ni with 2 hydroxides. And since it's polyatomic, it has to be in parentheses. OH with a subscript of 2. And on top of that, we're going to have sodium. And I'm just going to tap this over here like this, go over, and we're going to put those together. Okay, so sodium, and then we have nitrate. Okay, so sodium, if I look at that, is a +1 again, a +1. Nitrate, if I know what it is from up above, is going to be a -1. So that means we have 1 of each one. So we're going to come down here, and we'll put our plus sign, and we're going to put down 1 of each one, 1 sodium, which is Na, and 1 nitrate, which is NO3. There we go. There we have our skeleton equation. So once you have our skeleton equation, we can go ahead and balance our skeleton equation. So we're going to go ahead and balance it. So I have nickel. On this side, I have 1 nickel. Okay. And if I tab over to the other side, I have nickel. I only have 1 nickel there also. Now again, this 1 nickel right here, because there's no subscript. Okay, we go to the next one. Next one, we're going to keep our NO3 together. So we're going to have NO subscript of 3. We have a subscript of 2, so we have 2 of those. On this side, though, we look at NO3, we only have 1. No parentheses, so that means there's only 1 of them. Okay, go back to the other side, we have our sodium, our Na, which I look up here, there's no subscript, which means that there's only 1 of them. Okay. On the product side, sodium is right here. There's no subscript. Okay, so that means we only have one right there. And we do our last one. We have our OH. Since I have OH on each side, so I have our hydroxide. On this side, there's only one because they're not in parentheses. So we're going to put a 1 there. We'll get over to the other side. Here, though, I do have it in parentheses. I have a subscript here of 2, so that means I have 2 on that side. So what are we going to do first? Well, it doesn't really matter what we do first of the ones that are not balanced. So we're going to go ahead and do nitrate first. So I have 2 nitrates here. I need 2 nitrates on this side. So I'm going to go ahead and put a 2 right there. Because remember, we can't change the subscripts. We can only change the coefficients. So we have a 2 right there. That means we have 2 nitrates. So I'm going to go over here. I'm going to put in a 2, and then I'm going to get rid of this one right here. Okay, we'll strike that through. And now my nitrate is, but it also affected my sodium. So now I have 2 sodium, so I'm going to go over here to my sodium, and I'm going to put a 2 there. And that gets rid of that sodium right there. So we're going to go ahead and get rid of that other number. And so now we can chase it to the other side. So we're going to chase it to the other side. I only have 1 sodium over there. So I have to put a 2 coefficient in front here, which changes that to a 2. And I can go ahead and get rid of this one right here. I'll do that. There we go. And so now I have 1, 1, 2, 2, 2, 2, but hydroxide. But oh, that's right. I have hydroxide up here. I have 2 of them. Remember, this 2 is multiplied times everything after it. So I have 2 sodium, but I also have 2 hydroxide. So we're just going to go ahead and put a 2 there. That gets rid of this 1 right there. And now we're balanced. So what is our balanced chemical equation? We have a 1, a 2, a 1, and a 2. So I'm just going to go ahead and highlight these in green so we know what we have. So there's our molar ratio. Okay, if I have a spot over on the side over here for a molar ratio, I do expect you to also put it there. Okay, but in this case we don't. So now what we're going to do is we're going to go ahead and start our stoichiometry. But before we can start our stoichiometry, we have to have some molar masses. Now again, we need molar mass of nickel nitrate of what we have, and we need a molar mass of what we are looking for. So we're looking for sodium nitrate. So we're going to start with this one right here, nickel 2 nitrate. So nickel 2 nitrate is this one right here. So I'm just going to pull this one to the side, and I'm going to copy it, and I'm going to drop it down here, and I'm going to talk about my molar mass. And so I'm just going to put that one right there. Okay, now I'm also going to go over here and do one that I'm looking for, which is sodium nitrate, which is this one right here, sodium nitrate. So I'm going to copy that one also, and I'm going to paste it over this way and paste it. Now what I'm going to do below that is I'm going to add up the totals of everything that I have. So we have nickel here. Okay, we also have nitrogen, and we have oxygen. Okay, on this side we have sodium, nitrogen, and oxygen. And I like to kind of do these at the same time. So we're going to go ahead and say, how many nickels do we have? Okay, we have 1 nickel. So 1 times whatever the molar mass of nickel is. So let's go ahead and look at the molar mass of nickel by looking at the periodic table. Find nickel. There's nickel is 59. So we'll go back here and we're going to put in 59. That's going to be 59. And 1 times 59 equals 59. Okay, let's go ahead and do the nickel, or the nitrogen. Nitrogen, I have 1 nitrogen right there, but I have it 2 times. So we have 2 nitrogens. Okay, that's going to be times our molar mass of nitrogen, and we look at nitrogen right here, and it is 14. So we're going to go back to this, and we're going to put in 14. So 2 times 14 equals 28. Okay, and then we're going to go ahead and do our oxygen. Oxygen, I have 3 oxygen, but I have it 2 times. So that means I have a total of, a total of 6 times the molar mass of oxygen. And we look at oxygen right there, it's 16. Okay, so we'll go back to our problem right here, and we're going to put in 16. And what that's going to equal. Now, I believe it's 96. Okay, and the way that I did that was I went 6 times 6 is 36. So there's my 6. And then I want 6 times 1 is 60, plus the 3 is 90. So 96, but we're going to double check that. So we're going to go in there, and how we're going to double check that? We're going to double check that by putting in or pulling up our calculator. And now that we have our calculator right over here, we're just going to take our 6 and multiply that by 16, and that's going to equal 96. So we're correct. Okay. Now, one thing that I'm going to do, I'm going to add the rest of them. So we're going to add to that, add 28, and then we're going to add 59, and that's going to equal 183. So my total is going to be 183 grams. Okay, that number we're going to use a little bit later. So we're going to highlight that number. Okay, we're going to highlight it in yellow, and then I'm going to go over to my sodium. Well, how many sodiums do I have? I look up here, the subscript's 1. There's no number in front of it, so we're going to put down 1. Okay, we're going to multiply that by our molar mass. So go back to our molar mass of sodium, which is 23. Okay, so we're going to times that by 23, and 1 times 23 equals 23. Then we go to our nitrogen. Okay, so I come down here, I have 1 nitrogen. We're going to multiply that by the molar mass of nitrogen, which we're going to find on our periodic table. There's nitrogen, right there it is, 14. So go back to it, and we're going to put 14. 1 times 14 equals 14. Then we're going to go to our oxygen. We have oxygen right here. We do have a subscript this time, so we have 3. So we know that we have 3 times our molar mass of oxygen. Find oxygen again. There it is, right there. Our molar mass is 16. It's that 16 right there. So we're going to go ahead and put in our 16. And that's going to equal 3 times 16. Now again, if we don't know what that answer is off the top of our head, we can take our 3, multiply that by 16, and we know that it's 48. So we're going to go ahead and put 48 right there. Okay, so now we're going to add all those up. And we're going to get a total over here. And we're going to put that in green, or in yellow. So we're going to do that where it's 48 plus 14 plus 23 equals 85. So we know that our total is going to be 85 grams. And again, I'm going to go ahead and highlight that just to help us out later on. So now that we have our molar masses of each one, okay, we're going to go down and start our stoichiometry problem. So our stoichiometry problem starts off with the number that's in the problem. If we go back up here, we wrote the skeleton equation, we balance it. We're going to start the stoichiometry with the mass that's in the problem. So right here's our mass that's in the problem. We have 0.73 grams of nickel. So we're going to come down here and we're going to put 0.73 grams of nickel nitrate, which is going to be this one right here. So we're going to take that one, we're going to copy it, and we're going to scroll back down, and it's grams of nickel nitrate. Okay. Now what we're going to do is we're going to do our times in the line, but we're going to do a little bit different. So we're going to put our times in our line right there. But we're going to start with what we're going to do on bottom first. So we're going to come over here, and we're going to put our grams, our molar mass. So we're going to put our grams on bottom because we got to get rid of this gram right here. So we're going to have grams of this, and I'm just going to copy this, and we're going to paste it on bottom. So we're going to paste it right there. Now, what is the molar mass? Well, the molar mass is what we calculated out. It's a 183. So we're going to put 183 grams there, and that's going to equal how many moles? Well, in molar mass, the weight of 1 mole is 1 mole. So we're going to put 1 mole on top. And that's going to be of our nickel 2 nitrate. It's not grams. Okay, so after that one, we're going to put our times in the line again. And we're going to put our molar ratio right here. So now we have this right here. And I'm going to just go ahead and highlight this real quick, or underline this. Okay, and I'm going to highlight my numbers, because you're going to get points for each one of these when it comes down to your final test. Okay, now we're going to do our molar ratio. We're going to do this, start with the bottom, because we have to get rid of what's on top up here. So we're going to get rid of what this is up here. So I'm going to come in here and we're going to put moles of nickel 2 nitrate. Okay. And then on the top, we have to put what we're looking for. So we're going to put moles of what are we looking for? We're looking for this one right here, sodium nitrate. So we're going to copy that, copy, and we'll paste that right there. Paste. Now again, how do I know for sure that's what I'm looking for? Well, I know for sure what I'm looking for that is because it's in the question. Determine the mass of sodium nitrate. And that's what we're going to do. Now, what are we going to do with the numbers in front of these? Well, we're going to go, this is, remember, here's our molar ratio. So we're going to go to our balanced chemical equation. We're going to find NiNO3, which is right here, and the number that's in front of that is 1 mole, is going to equal how many moles of sodium nitrate? Well, sodium nitrate is going to equal 2, so we're going to put a 2 right there. Okay, so we can go ahead and underline that. And now we can go ahead and highlight just the numbers again, and we'll turn them yellow again. Okay, now we have it in moles. Okay, so we have it whatever's at the top. So now we got to go ahead and finish that. So we're going to go ahead and tab over, and we know that we're going to have our molar mass again. So we're going to put 1 mole of NaNO3, and over top of that, we're going to put down our grams of NaNO3. But where's our grams coming from? Well, our grams for this comes from our molar mass that we got. 1 mole equals our weight. Okay, and so we're going to look at this right here, and we're going to put that number right there. So we'll put 85. Okay, so now I can go ahead and highlight those numbers. And we're going to underline it. So now we have our 3 steps already done, but what we have to do now is go ahead, okay, and we have to put our equal sign, and that's going to equal grams of NaNO3. Okay, so now what we can do is we can get rid of any type of unit that we can get rid of, and what's nice is we can get rid of this unit. Okay, so I'm going to go ahead and get rid of that one with a straight through. I'm going to get rid of this one with a straight through. Now again, you don't have to do straight through. You can do shade it with a highlight of a darker color. But remember, I need to be able to see through it. So go ahead and do that. I like the straight through just because I can definitely read what you have right there. And you can't just delete it, because if you delete it, I don't know if you're actually doing the work or not. And we'll get rid of this one. Now again, once I get through all that, I have grams of sodium nitrate, and that's the only unit that I have left. So I know that that has to be in my answer. So let's go back up and see if that's what it has. It has for the mass of sodium nitrate. Well, mass is in grams, so that's what we're going to look for. So now what we're going to have to do is all we have to do is go ahead and do our math again. Now remember, we're going to take our original number, we're going to multiply by the top, divide by the bottom. Multiply by the top, divide by the bottom. Multiply by the top, divide by the bottom. But if there's a 1, we don't have to do that step because 1 doesn't change the answer. So we're going to start off with our 0.73, and we don't have to multiply by 1, but we do have to divide it by 183. Then we're going to multiply by the top of the next one, which is the 2 right here, this 2. So we're going to multiply by 2. And then we're going to divide by 1, but we don't have to do that one. Then we're going to multiply by 85. And then divide by 1, which we don't have to, hit our equal sign. And that's the number that we end up with. So we're going to end up with 0.6781. So we're going to end up with 0.6781. And now we have to round to our correct number of significant figures. So let's go back up to the original problem. And there's our number that we have right there. This 0 is never significant because preceding zeros are never significant. So I have two significant figures there. So that means I have to go after the first one, 1, 2, put my line right there. And I like to go ahead and insert some type of special character. In this case, just an arrow pointing down. And so I have it there. And so when I get here at the end, I know that my final answer, or my rounded answer, is going to be 0.6. And now I got to look at this. The 8 says I round up the 7. So that turns to an 8. That's going to be grams of sodium nitrate. My last step that I have to do is go ahead and highlight that one right there. And again, I like to highlight all my answers in green. And we're done. So there we go. The answer to question number 2 of practice number 3, okay, ends up being 0.68 grams of sodium nitrate. Hey, that's it. Good luck with the rest of them. As always, go Mohawks. Nelson out.